Okay, so we'll discuss today the combination of pulleys section from the textbook and what are the relevant sections in terms of the syllabus, what has been excluded and what is still part of the syllabus. Actually, in terms of pulleys, there has been no exclusions from the syllabus. So you can expect all the sections from pulleys to come for this. So the combination of pulleys, read that section that has been given over there. It just gives you an explanation of certain things using one fixed pulley and other movable pulleys. So this diagram is of course slightly different from the one that I have used for my teaching, but you will realize that the way in which it works is almost exactly the same. So figure 3.24, just to see, you don't have to draw the multiple movable and fixed pulley system in this form. In any case, they haven't asked anything like that in the last 5 or 6 years that I can remember. At worst, they may give you the diagram and they may ask you to find out something, ask you to calculate something about it. So you should be familiar with this way of drawing the multiple movable and fixed pulleys diagram. So in this way of drawing it, you can see that only the movable pulleys are drawn, and there is only one final fixed pulley, and that is obviously for changing the direction in which the effort is applied. Then moving on to the mechanical advantage. So based on this diagram, now they are working out what is the mechanical advantage that is there. I urge you to study this section about how the mechanical advantage is calculated, but you will probably not be asked to do any such derivation, general derivation. So what you are more likely to be asked is, given a set of pulleys, they will give you what is the load, they will give you what is the effort, and they'll ask you to calculate the mechanical advantage using the formula for mechanical advantage. Okay. But however, you are expected to remember this formula that comes at the end, which is that when there are n number of movable pulleys and one fixed pulley, the mechanical advantage can be calculated as 2 power n. Okay, so going back to this diagram, you can see that there are 3 movable pulleys and one fixed pulley. So the mechanical advantage in this case will be 2 to the power of 3, which will be 8. Okay, and you can check the diagram and see if that works out to be true. Then the velocity ratio, you can go over that section and you can find out. You will find obviously that the velocity ratio is exactly the same as the mechanical advantage, which is also 2 power n. If you study the derivation, then you will understand it. If you study it and you didn't get it, it's all right. All you need to do is you need to remember, for pulleys, if there are n number of movable pulleys and one fixed pulley, then the mechanical advantage will be 2 power n. Then there is a small section on efficiency. Obviously, if mechanical advantage and velocity ratio are the same, then you are going to get 100% efficiency. So ideally, there will be 100% efficiency if there is no weight, etc., of the pulleys, the ropes, and the friction, if they are not taken into account. Then using several pulleys in 2 blocks, that is the block and tackle system, read the entire section in order to understand like some of the arguments, why they use a block and tackle system and so on. But of course, the most important thing is to be able to actually draw the block and tackle system and then to work out the mechanical advantage from the given diagram. Okay, so often asked question, once every 2 or 3 years it repeats. I'm repeating myself also. They either ask you to draw the block and tackle system, or they ask you to use a diagram that has been given to do the calculations. Okay, so a variety of different types of questions can be asked on this. The exercise will reflect the types of questions that will be asked. So please make sure that you work out the numerical problems on your own. Okay, so don't write down answers from other people or take down answers from the guidebooks and so on. Make sure that you understand it. If you know it, if you know how to do it, it's pretty easy. It's very good scoring opportunity. So trouble yourself a little bit to study this and to know it fully well, so that you can tackle any kind of question that is asked. So numerical questions are almost guaranteed from this section. So that is why I am emphasizing this. Then going on to the second column, mechanical advantage, it shows you how to calculate the mechanical advantage of a block and tackle system, how to find out the velocity ratio of a block and tackle system, and the efficiency. In general, in machines, always take into account whatever the type of machines, and for you people it has been simplified quite a lot. There's only levers and pulleys. Figure out how to know or how to find out what is the mechanical advantage, what is the velocity ratio, and what is the efficiency. Okay, so these three things are almost guaranteed to be asked. One thing that you need to take into consideration is, in case the efficiency number, the eta, is not 1, if it is less than 1. So if there are some losses in the system, how to account for that in your calculations. So that will not come out of me telling you anything. Okay, that kind of knowledge or information or capacity or skill will come only by practicing. My suggestion is, please pull out the past 4-5 years paper. There are good books in which the compilation of those papers are there. Pull out all the numerical problems that come in there. There are 2, 3 or 4 types of numerical problems that repeat themselves, and make sure you are thorough with all of them. So that is a good way to prepare for these kinds of questions. Then there is a small section, let's just read through that. The pulley system is only a force multiplier, and just like other machines, there is no gain in energy. This can be seen, oh, okay, blah, blah, blah. Okay, this is the basic argument in any case. And then finally, the effect of weight of pulleys on mechanical advantage, velocity ratio, and eta. You can read this section, but they don't expect you to answer any questions based on this. Okay, so this is not a part of the syllabus as of now, and so therefore you can omit this section if you are not interested. So that is purely for your interest. And with that we come to the end. You can also select 1 or 2 questions from the examples and try to solve them if you are able to understand it. And then the assignment 3B, I'll post the assignment tomorrow after your test is over. So unless there are any other questions, we'll stop.